Hello dear students, welcome once again to your online class. So we'll continue with chapter 3, laws of motion. Today we'll discuss about the linear momentum and the Newton's second law. So coming to the term linear momentum, what is linear momentum? The linear momentum is the product of mass and a velocity. Suppose a body of mass m is moving with a velocity v. So the linear momentum is given by the formula m into v. So the linear momentum is literally the product of the mass and the velocity of a given object. Now coming to the unit, the linear momentum is a scalar quantity and it has a certain unit by which it can be measured. So the unit of mass in terms of SI system is kg and the velocity is meter per second. Thus the unit of linear momentum is kg meter per second. So from this formula we see that the linear momentum depends upon the two quantities. One is the mass and the second one is the velocity, and both of them they are directly proportional to the linear momentum. That is, the greater is the mass, the more will be the linear momentum, or the greater is the velocity, the higher will be the linear momentum. So the linear momentum is directly proportional to the mass also and directly proportional to the velocity also. So from this concept of linear momentum, we can thus define the Newton's second law of motion, which states that the force acting on a body is directly proportional to the change in its momentum, and this change takes place in the direction at which the force is applied. So if I want to write it in a mathematical term, I may write it as the force applied is directly proportional to the rate of change of momentum. That is, I can write del P. What does this del signify? The del signifies a small change during a small time interval t. So this is the mathematical expression for the Newton's second law of motion. F is directly proportional to del P divided by del T. So in words you can say as the force. So in words you can define it as the rate of change of linear momentum is directly proportional to the force applied, and this change takes place in the direction in which the force is applied. So using the Newton's second law, we can easily derive the formula the force equals to mass into acceleration. So let us try to derive this, and this derivation is very important from your examination point of view. So beginning with the statement, what does the Newton's second law tells us? It tells us that the force applied is directly proportional to the rate of change of momentum is directly proportional to the force applied. So it is directly proportional del P divided by del of T. So in the next step, what can I do? I can write F is directly proportional to del. Now instead of writing P, I can substitute the value of P, that is m into V divided by del T. Again, F is directly proportional to del. Now suppose if you are running, what happens? Or if you are running and if somebody pushes you, what happens? Does your mass change? No, our mass remains constant, but what can change is the velocity. So I make this change only for velocity. So I take m out and I put del V. It is because the mass cannot change. Even when the force is acting on a body, the mass of the body remains the same. So hence there is a change only in the velocity. So divided by del of T. So I can write F directly proportional to m. What is del V divided by del T? From the definition of velocity, from the definition of acceleration, we have that the acceleration is the rate of change of velocity. So thus for this del V divided by del T, I can substitute A. Why? Since I have defined the acceleration as it is the rate of change of velocity. Hence now I almost got the equation F equals to ma. Now to remove this proportionality sign, we insert one constant. So I can write F equal to K m A. What is K? K is a constant. And the force, mass and acceleration is chosen in such a way that the value of K is equals to 1. So we can write since K equals to 1, therefore I can write F equals to m into A. So thus we get the expression, the force equals to mass into acceleration. So from this we get the definition of force. So now coming to the units of force, units. So what is the unit? Since the mass is measured in kilogram and the acceleration is measured in meter per second square in SI unit. So therefore the SI unit of force can be given as, like it is kg meter per second square, and this kg meter per second square can also be termed as a Newton. And the CGS unit. So in CGS unit the mass is measured in terms of gram and the acceleration is measured in terms of centimeter per second square. And this gram centimeter per second square can also be said as a dyne. So thus the SI unit of force is Newton and the CGS unit of force is dyne.